An Azure storage account is one of the most underexplained resources in Azure because it quietly does 4 very different jobs. In the next few minutes, we'll build a single general-purpose storage account end-to-end and wire up all 4 data services inside it. Blob storage for unstructured objects, Azure Files for SMB shares, queue storage for messaging, and table storage for key value data. I'll show you the decision at each step, what to pick and why, and how to lock it down with the right access model. By the end, you should be able to rebuild this from memory. First, the mental model. At the bottom is the storage account itself, which is mainly a billing, redundancy, and security boundary, plus a globally unique namespace. On top of that sit the 4 service endpoints, each with its own URL, blob.core.windows.net, file, queue, and table. Inside each service, you have containers for blobs, file shares for files, queues for messages, and tables for entities. Understanding this layering matters because redundancy and most network rules are set once at the account level and apply to everything underneath. You don't get a separate region or replication setting per blob container. Now we create the account. 3 decisions dominate. First, account kind, choose General Purpose v2, which supports all 4 services and all access tiers. Second, performance, standard runs on hard disks and is fine for most workloads. Premium uses solid-state disks for low latency, but Premium is service-specific, so you pick Premium block blobs, Premium file shares, or Premium page blobs separately. Third, redundancy. Locally redundant storage, LRS, keeps 3 copies in one data center. Zone redundant storage, ZRS, spreads copies across 3 availability zones. Geo-redundant options, GRS, and geo-zone redundant storage replicate to a paired region for disaster recovery. Pricing and exact options change, so check the current Azure docs before committing. With the account live, start with Blob Storage, the workhorse for images, backups, logs, and data lakes. Create a container and set its public access level to private by default. Each blob can live in an access tier, hot for frequently read data, cool for data accessed maybe once a month, cold for rarer access, and archive for offline retention that needs rehydration before reading. The trade-off is storage cost versus access cost and latency. Add a lifecycle management policy to automatically move blobs from hot to cool to archive after a set number of days. If you need a hierarchical namespace for analytics, enable Data Lake Storage Gen 2 at creation time because you can't add it later. Next, Azure Files. Create a file share and you get a fully managed SMB or NNFS share with a UNC path you can mount from Windows, Linux, or macOS or sync on-prem with Azure Files Sync. This is the drop-in replacement for an old file server, and it's the one service that supports the SMB protocol directly. Then queue storage, create a queue and you have a simple, durable buffer for asynchronous work. Producers post messages up to 64 kilobytes, consumers pull and delete them with built-in visibility timeouts so a crashed worker's message reappears. For richer messaging features like ordering, topics, or larger payloads, reach for Azure Service Bus instead. The 4th service is table storage, a schemaless key-value store. Every entity is addressed by a partition key and a row key, and that pair is your only index. Get the partition key right and reads are fast and cheap. Get it wrong and you'll do expensive table scans. It's great for telemetry, device state, and user metadata where you query by a known key. But know the ceiling, there are no secondary indexes and no complex queries. If you need those or global distribution and guaranteed low latency, move to Azure Cosmos DB, which offers a table API that's wire compatible, so your code can migrate with minimal changes. Now secure it. You have 3 access models. Account keys are the master keys for the whole account. Treat them like root passwords and avoid handing them to apps. Shared access signatures, SAS, are scoped, time-limited tokens for narrow delegated access. Best practice for Azure workloads is Microsoft Entra ID with role-based access control, so assign data plane roles like Storage Blob Data Contributor to a managed identity instead of sharing keys. On networking, disable public blob access, restrict the account to selected virtual networks, or front it with a private endpoint so traffic never leaves the Azure backbone. Always confirm encryption at rest is on, which it is by default with Microsoft managed keys. So here's the whole build. one general purpose V2 account as your boundary where you set performance and redundancy once. Inside it, blob storage with access tiers and lifecycle rules, Azure files for SMB shares, queue storage for async work, and table storage for key value data with its partition key discipline. And you secured all of it with Entra ID role assignments and a private endpoint instead of leaking account keys. One concrete takeaway: go disable key access on a test account and switch your app to a managed identity with the Storage Blob Data Contributor role. It's the single highest value change you can make. Pricing and tier options shift, so verify the current Azure docs before you go to production. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.